All right, let's talk about something you probably see every single day, but maybe don't think too much about. Clouds. They look so simple, right? Just these light, fluffy things drifting across the sky, but they're hiding a secret that is, well, absolutely massive.
I mean, when you picture a cloud, this is what comes to mind. It's like a puff of cotton candy just floating up there. You'd never think of it as having any real weight, right? The word weightless just seems to fit perfectly. How could it not?
But what if we could actually weigh one? Take one of those average, everyday cumulus clouds and pop it on a giant cosmic scale. What do you think it would weigh? A few pounds? Maybe a ton? Go on, take a guess. Because the real answer is probably not what you're thinking. Not even close.
Get this, 1,000,000 tons. Yeah, you heard me right, that's not a typo. Your average fluffy little cloud weighs about the same as 200,000 elephants. It's an unbelievably heavy object floating right over our heads.
Okay, let's dive into this, because how does that even work? How can something we think of as completely weightless actually weigh 1,000,000 tons? That's the puzzle we are going to solve right now.
So the first piece of the puzzle, the first clue, isn't about what a cloud is made of. It's about its sheer mind-boggling size. We see them from so far away that it's really hard to appreciate just how gigantic they are. A typical cumulus cloud takes up about 1 cubic kilometer of space. Now, that is a massive, massive volume. And every bit of that space is filled with countless tiny, tiny water droplets.
To really get a sense of that, just try to picture it. Imagine an invisible box in the sky. It's 1 kilometer long, 1 kilometer wide, and it stretches a full kilometer straight up into the air. That entire volume, that's the cloud. It only looks small and manageable because it's so incredibly far away.
And this brings us right to the heart of the paradox. We've got this object that weighs 1,000,000 tons, sitting in this enormous box right above us. So the big question is, why doesn't it just fall? Why doesn't gravity just pull it all crashing down to the ground?
The answer, the real secret to how a cloud floats, all comes down to one simple concept from your old physics class: density. This is the key that unlocks the whole mystery.
So let's do a quick refresh on what density actually is. It's not just about how heavy something is. It's about how much of that heaviness or mass is packed into a certain amount of space. It's the stuff per unit of volume. Okay, so here's the magic number. The density of a typical cloud is about 1.003 kilograms per cubic meter. Now, that number by itself doesn't really tell us much. What really matters is what we compare it to.
And this right here, this shows you everything. Just look at how incredibly close those bars are. They're practically identical. The cloud has a density of 1.003 kilograms per cubic meter, but the dry air around it is actually a little bit more dense, sitting at about 1.007.
And that tiny, tiny difference is everything. Even with 1,000,000 tons of water droplets inside it, the cloud as a whole is about 0.4% less dense than the air it's sitting in. It's basically a gigantic 1,000,000-ton hot air balloon. It floats for the exact same reason a huge steel cruise ship floats on water. Its total density is just a little bit less than the stuff it's displacing. So let's just put it all together one last time. It's really a simple three-step thing. 1, clouds are enormous. 2, inside that enormous space, there's a staggering amount of weight. 1,000,000 tons of water. But 3, and this is the kicker, all that weight is spread out so much that the cloud becomes just a tiny fraction less dense than the air surrounding it. And that's why it floats. So the next time you look up and see a fluffy cloud just drifting by, remember what you're actually looking at. You're watching something with the weight of a whole fleet of jumbo jets float peacefully overhead. It really makes you wonder, doesn't it? What other simple, everyday things are we completely wrong about?